Hello Math 8 students, this is a review in preparation for our end of unit transformations unit. We're taking our test tomorrow, so we're reviewing today. Last year when I gave this test, students struggled on certain questions, not because they didn't know transformations, but because they didn't know definitions of these things. So we're going to talk there first, make sure that we have a good solid understanding. Congruence, what's the definition of congruence? Seth? Yeah, nicely done. Yes, congruence is, we would say, figures are said to be congruent and you can be as formal or as informal as you want in this. I'm going to be formal in my official definition, but you can say they line up. That's okay. You can just say we can move from one to the other. But I'm going to say figures are said to be congruent if one can be obtained from the other. Through a sequence of rigid transformations. And it doesn't always have to be a sequence, it can just be a single transformation. It could be a combination of multiple, but a sequence of rigid transformations. That is the definition. Before I define the rest of these, I want to point out why it's so important to know the definition. If you jump ahead to question number 16 through 19, you're going to see the instructions are specifically use the definition of congruence to determine if the pair of figures are congruent. So that means we have to know that definition so that we can use it. You can't just say, yes, all the angles are the same and all of the side lengths are the same. If you want to say yes using the definition of congruence, you have to describe that sequence of transformations. Let's just go ahead and do 16 right now. Yes, they're congruent. Yeah, you don't have to draw anything. You just have to use the definition of congruence. Are these congruent? I'm going to say yes, but I'm going to prove it by saying I can translate 2 units to the right and not 2 units. Let me recount that. 3 units to the right. And 1, 2, 3, 4 units down. Notice the words I'm using. I'm not saying just move it. I'm using those precise mathematical terms, translate. And I'm not stopping with it's a translation. I'm describing that sequence of transformation. So translate 3 units down. And nope, that is incorrect. 4 units down. 3 units right. That is using the definition of congruence. So you need to know the definition of congruence so that you can use it to prove whether or not figures are congruent. Let's go back to those definitions. I'll let you finish up those other ones in a second. Let's do these definitions. Students in class have already discussed, so let's see what they know. Quadrilateral. What is the definition of a quadrilateral? Be precise here. What's the definition? Yes, Hayden. Yeah, that's really it. It's a 4-sided figure. Quad means 4. Lateral means sides, so 4 sides. Okay, they get trickier now. Parallelogram. What's the definition of a parallelogram? Sam? It does, that's part of it. Yes, Seth? Yes, I'm going to go just one step further, and we're not just going to say a figure. We're going to specify that it's a quadrilateral. Yep, a 4-sided, yep. So a quadrilateral key word here is it's parallelogram, so a quadrilateral with 2 sets of parallel sides. You can draw a parallelogram as an example. Sometimes visual representations really help us solidify our understanding. interesting things to note. Because we have two sets of parallel sides, that also means that these opposite sides that are parallel to each other are also going to be the same length. So two sets of parallel sides, that's not part of the definition, it's just a unique characteristic. Two sets of parallel sides, we'll say opposite sides are congruent. If you want to draw a picture for a quadrilateral, I try and make it as non-specific as possible. Even though a four-sided figure could be a rectangle, I like to save a rectangle shape for that rectangle. This is just randomly four-sided. Nothing unique about the side lengths or the angles or anything. Okay, let's go deeper. Rectangle. Precise definition of a rectangle. I want to see more hands. Go back and discuss if you need to. We'll come back together in 10 more seconds, but discuss. I want to see lots of hands. Okay, come back to me. Rectangle, give it a try. You've had a chance to check in again. Daxton, give it a try. How is that different than a parallelogram then? Are all rectangles parallelograms? Are all parallelograms rectangles? So, Daxton, you haven't said anything true, or you haven't said anything false. You haven't said anything incorrect, but it's not quite precise enough. Let's go deeper. What is this a rectangle? Because this is a four-sided figure with two sets of parallel lines. Is this a rectangle? So how do I need to change it? What is unique about rectangles? Kaden? Well, but that's what we have here, right? Is this a rectangle? What do rectangles look like? Gabe? All the angles are 90 degrees. Are all rectangles still parallelograms? Are opposite sides parallel? Yes, but is that enough to make it a rectangle? Again, here's a great picture. Is this a rectangle? No. So we've got to go further. A rectangle, and again, I'm going to continue reusing previous definitions. So I'm not just going to say it's a quadrilateral. I'm not going to say it's a four-sided figure. I'm going to say it is a parallelogram, because it is. Opposite sides are going to be parallel. So a parallelogram with the added characteristic that all angles are right angles. Yes, Seth. You can say 90 degrees. That's fine. Yep. I'm going to draw an example. Again, opposite sides here are going to be parallel. Opposite sides are the same length. But now I'm adding this characteristic that each one of these angles is a right angle. Okay, go a step further. A square. We'll pause again, let you guys discuss. Now that you see quadrilateral, parallelogram, you see rectangle, what is the definition of a square? Check in with your groups one more time and let's see lots of hands. Let's go 15 seconds to discuss. Okay, now come back to me. Give it a try, Siley. All four sides are equal, and we have to be careful about all parallel, because if they're all parallel, it would have to be like that, right? And then it's not a figure anymore. So, okay, so all sides, not all sides, opposite sides are parallel. Angles are 90 degrees, and what was the other characteristic you said? Side lengths are the same, right? Yes. So, again, I'm going to reuse some previous definitions. If you're saying all angles are right angles, all angles are the same, and you're saying it's already a parallelogram, there's a word that I could use for that, right? A rectangle. So we're going to say a square is a rectangle. Students don't often realize that, especially in kinder when they're first learning their shapes. Squares are actually rectangles, but it's a rectangle with the specific condition that all sides are congruent. Now this is included, this information of them all being 90 degrees is all the angles being 90 degrees is already part of it being a rectangle, but probably still worth mentioning anyway. It is a rectangle. That means it has 90-degree angles with all sides congruent. So let's put in parentheses, since it's a rectangle, all angles are right angles. The next one is a shape that students often struggle with. Here, let me draw that one first. That is not a good square. Will you guys forgive me? It's probably about as perfect as yours is, so you guys will be forgiving, right? I am going to add the marking showing that all of these side lengths are the same. So even if they're not drawn perfect, those side lengths remind us that yes, those markings remind us that yes, those sides are the same, just like my angles are right angles. Rhombus, what's the definition of a rhombus? Go back and discuss with your groups one more time because I really want a good attempt here. Rhombus, what is a rhombus based on all these other definitions? What is a rhombus? Okay, come back together. Let's give it a try. I'm going to call on Emery. I liked her comments. Emery. It does look like a parallelogram. So how is a rhombus different than a parallelogram? Because you're right, they do have a very similar look. How's it different? I want to see if there's anyone else. I've heard from all you guys. Appreciate your engagement. No one else? Okay, we know whose citizenship is being adjusted. Seth, go ahead. Okay, so it's like a parallelogram, but also kind of like a square. All of the sides are equal, but in this parallelogram, the angles aren't 90 degrees, whereas square they are. So it's kind of like a parallelogram. We're skipping the step of a rectangle and kind of going into a square. So a rhombus is a parallelogram. It's not a rectangle because it doesn't have 90 degrees. A rhombus is a parallelogram. Similar to a square in that all the sides are congruent. So let me ask you this. If a rhombus is a parallelogram with all sides congruent, is this a rhombus? Is it a parallelogram? It is a parallelogram. Are all sides congruent? Is this a rhombus? But if the definition of a rhombus is a parallelogram with all sides congruent, is this a parallelogram? Are all sides congruent? Is this a rhombus? Check with your groups. Discuss. Okay, now come back to me. One more time. We see that this is a parallelogram. We see that all side lengths are congruent. Is this considered a rhombus then? The same hands. I'm going to cold call. We're going to go off with someone who's not raising their hand. Let's go to Ethan. Is this a rhombus? Why? You have to convince me because I'm pretty convinced that it is. It says parallelogram and I see it's a parallelogram. It says all sides congruent and I see that all sides are congruent. So tell me why it's not a rhombus. Why are you concerned about it being a rhombus? Let's go, Peyton. Help him out. Two sets of parallel angles? What do you mean by two sets of parallel angles? Okay, the angles can change. That is a true statement. Parallelogram with all sides congruent doesn't tell us anything about the angles, so you are correct. But could this be a rhombus? Emery? Yeah, that's the same thing that Peyton said. All true. A rhombus, not any angle that we want, but they're not defined, right? In a square, they're defined. Is this a rhombus? Take a look and see. Is it a parallelogram? Yes. Are all sides congruent? Yes. Therefore, is it a rhombus? Yes. Is it also a square because it has even more information than we're normally used to seeing for a rhombus? Yes. Understand what's happening here. This is a golden retriever. Is a golden retriever a dog? Yeah. So is this a dog? Yeah. Is it a special kind of dog? Yes, it's a golden retriever, but a golden retriever is still a dog. Okay, make that connection there. So, a parallelogram with all sides congruent. Here's what I want you to understand. Could all of the angles also be congruent, like in a square? Yes, not typically. We normally don't see that. Because normally if we see that, we're not going to call it a rhombus, we're going to call it a square. Parallelogram with all sides congruent. Angles aren't necessarily the same like in a square. However, once again, this meets the definition of rhombus. It is a parallelogram. All sides are congruent, so this is a rhombus. So let's draw two examples here. That is a rhombus. That's typically how we see them, but please understand this is also a rhombus. It's just a special rhombus that has a different type of name. And again, even if you're not drawing them super precise, if you have some small mistakes, show that all sides are congruent by marking that they're all the same length. And now that we have spent 19 minutes just on vocabulary, now let's actually practice this. So you're going to see a bunch of different types of problems that you've seen before on different assignments. So nothing is new. This is all just a review. What I want you to do, since we don't have a whole lot of extra time, I want you to go through, read each type of problem, and I want you to pick the hardest ones. Let's focus on doing the hardest ones in class. For example, jump all the way ahead. You guys are pretty experienced with reflections, right? Is that one that we need to take time to do in class or one that you should just do at home? Maybe we won't spend our time there. Rotations. Maybe you're not quite as comfortable with rotations. Maybe this is one that you want to spend time and do together. That's fine. But if you feel confident with rotations, let's not ask to see that one. Again, look ahead to number 25. We've seen problems like this a lot. You guys all just aced a quiz on it yesterday. Do we really need to spend time going over something like this? Probably not. Jump down to 27. We've got some added information. Is that one that maybe we want to give it a try? Okay, so I'm going to give you guys 5 minutes, go through, see which ones you want to focus on completing in class today, and then we'll focus on those ones. I'm going to pause recording as students look in the review and find which ones they want to go over together. Ready, set, go. Number 7, even if nobody chooses to go over this one, I'm choosing to go over it, which means you should probably be paying attention. If I'm choosing, it probably means something, right? Multi-step problem. Draw a line segment in the space to the right. I drew the line segment and I labeled it AB. Okay. Draw a point not on the line segment. We're going to label that point P. Here's my point not on the line segment, P. Says we're going to rotate AB 180 degrees around point P. Remember, P is not on the line. When I do that rotation, you'll need tracing paper. I'm just going to do it quickly on my own. There's 180 degrees. There we go. And I just have to get into place. What's the relationship between A prime and B prime? D. What is that relationship between those? Describe that. You saw it on my screen, so quickly check in with your groups and describe what you just saw. What's that relationship? Okay, and I just heard it. It was almost in unison. What do you know about AB and A prime, B prime? What's that relationship? Lance. They're parallel lines. That's going to come up on your test. That's why it's been asked on your homework multiple times, asked again on the review. Make sure that you understand that relationship. We've done it even in our calculator when we've done our explorations. You've seen it lots of times, so don't forget that part. This is one other one that I want to go over, and then I'll open it up to ones that you want to go over. I want to go over this because on your congruence quiz, there was a very, very, very common mistake. So I want to quickly talk about corresponding parts. We have here, we talked about the notation, triangle XYZ is congruent to triangle QRS. And then I'm asking, okay, if that's true, angle Y is congruent to what? Now this is kind of hard. The triangle looks like maybe it's a rotation, but it's kind of hard to tell. So I want you to see that the information that you need is right here in the label. It says triangle X to Y to Z, that's X to Y to Z, is congruent to triangle Q to R to S. So what angles line up? That's going to be X and Q. I'm going to mark them. Let's keep on going. Y and R. So here's Y and here's R. And lastly, Z and S. So here's Z and here's S. Okay, this is important. Not only just for angle Y is congruent to angle R, but what if on this exact same problem, instead of just asking an angle, I wanted to be really precise and I wanted to know the segment YZ. Please discuss with your group. YZ is congruent to what segment? Talk with your groups real quick. Okay, and now to me, let's see the hands. Danielle. Yes, it would be congruent to RS, segment RS, and what I saw in your quiz when you did this, you said it was congruent to SR. So I took away half a point and I reminded you that it needs to be switched. And that's important to note because when you say that it's SR, that means that S would match up with Y. Does it? No. Those ones don't. So we need to make sure that we're really careful with all of our corresponding parts. So I did 8 with you. I'm not going to do 9 with you. I've given you the hints that you need to be successful with 9, but you need to do 9 on your own. And now those are the ones that I feel like we needed to go over probably the very, very most. Which ones do you guys want to see? Any others that you need to see done? Sam. 27? Yeah, I knew that one would come up. Baby step it. You might not know all of them right out of the gate, like if it were just parallel lines, but you know enough. So focus on one thing at a time. Notice that this right here is 62 degrees. That's part of a triangle. Okay, so we know that all of those will add up to 180. And since I don't know 5 or 6 yet, then I'm not going to worry about that. I have this measuring 110 degrees. Based on this measuring 110 degrees, what else do you know? Seth. Yeah, angle 2 is also going to be 110 degrees. We know that because of corresponding angles. So 2 is also 110 degrees. Okay, what else do we know? If we know those ones are 110 degrees, there's still some other angles that we can find. Sam, tell me another angle. Number 5. How do you know angle number 5? Yeah, exactly. So 110 degrees plus angle 5 should equal 180 degrees because of supplementary angles. So 110 plus 70 degrees is what it takes to get to 180. If I know angle 5, I know many other angles. If I know angle 5, we can figure out angle 8. How do I know angle 8? What's that relationship here? Kaden? It's not corresponding. What's the property? Help him out, Hayden. Vertical. Yeah, that one's vertical angles. Yep. So we also know angle 8 is 70 degrees. There's more angles that we can figure out. What else do you know, Daxton? Supplementary angles, because this is already 110. This is going to be 70 degrees to make it 180. We also know that one by corresponding, so we could have used that property as well. Okay, I know a lot of things. This should be pretty easy now. Seth, tell me something else. Ooh, 4 is not 110. Here's what you have to be careful of. Is this right here forming a 180 degree angle? No, we have to keep on going all the way to here to get to that 180. So it's not just 70 plus this is 180. It's 70 plus this plus that 62. So let's make another adjustment to that. We do still see supplementary angles, but it happens among 3 angles. Hayden. 48 degrees. Good. Now let's check that. 62 plus 48, that is 110, plus that 70. That gets us there. So it's just 6 and 7 we got to figure out now. We do have enough information. How do I find angle 6? Siley. Exactly. 62 plus 70 plus angle 6 is going to be 180 because they're all the angles of a triangle. So I can add those up. 62 plus 70 is 132. Subtract 132 from 180 and we get what? Siley, have you done that? Yeah, 48 degrees. Guess what? We didn't have to use the angles of a triangle. Can you also see it's another, it's another parallel line cut by a transversal. So we could have used alternate interior angles there as well. And last one, now that we know that that one is 6 degree, angle 6 is 48 degrees, you need to find angle 7. I'm not doing that one for you. You can do that one on your own. That part becomes homework. I bet you can figure that one out too. How are we going to figure out angle 1? I can see corresponding, I can see vertical, I can see supplementary, I can see alternate interior. There's lots of ways that we can find angle 1, so I'm going to leave angle 1 and angle 7 to you guys. Okay. All right. Any others that you want to see? Feeling pretty good? Let's review 12 and 13 then. Those were some of our weaknesses on our quiz. So let's review maybe 12 and 13. Ooh, 14 is even better. You're right. Let's go 12 and 14 then instead of 12 and 13. Let's do 12 and 14. Number 12. This is that property that you guys struggled with. Exterior angles of a triangle. We know that all the angles in a triangle add up to 180 degrees. Yes, but we also know a straight angle is 180 degrees. So there's multiple ways that we can do this, but the easiest way is understanding that this exterior angle right here is equal to these 2 angles added up together. Okay? Because these 2 angles added up together, plus this one will be 180. This plus this one will be 180. Using both supplementary and angles of a triangle, or triangle angle sum. So with that in mind, 144 minus 110 is equal to 34 degrees. Let's confirm. 110 plus 34 degrees is 144. What would this angle right here have to be, Ethan? 36 degrees, both ways, because 36 plus 144 is 180. 36 plus 34 plus 110 is 180. Now put that all to use. Take a look at number 14. Multiple properties going on here, but it's totally possible. So everyone focus your attention on 14. Before I do it with you, try and do it on your own. We've got supplementary angles, we've got vertical angles, we've got triangle sum theorem. No parallel lines here, but we've got all those other properties that we can use. So give it a try with your groups. We'll come back together in 30 seconds. I'm going to pause the recording. Tell me something that you know. Peyton, get us started. Yep. Good. We have vertical angles. 105 means this one is going to be 105 due to vertical angles. Good. What else do I know? Let's go Daxton. Good. Supplementary angles. I love that you guys are using the vocabulary. We have supplementary angles. It adds to 180. 140 of it is already here. There's 40 more. Last angle, the question mark, the one I'm actually after. Ethan. Good. What's left to get to 180, right? All the angles of a triangle add to 180. 105 plus 40 is 145 plus 35 more will give us our triangle sum of 180 degrees. All right. That's it for this review video. Anything that you have not finished in class is homework. Please do it. It is really important that you're doing these problems in preparation for that test. And the answers are already in Canvas. So after you do these problems, log into Canvas, check your answers. That way you can feel good going into the test instead of coming in with questions. That's it for the lesson video. Thanks for watching. We'll see you next time.